So we have these three trig functions, sine, cosine, and tangent, and they each relate a pair of sides in a right triangle. Sine relates the opposite side to the hypotenuse. Cosine relates the adjacent side to the hypotenuse. Tangent relates the opposite side to the hypotenuse. So based on an angle, we can figure out what that ratio is, or based on a ratio, we can figure out what that angle is. Given two pieces of information here, we can find the third piece of information. An easy way to remember this is SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So you might hear people say SOHCAHTOA just to help you remember the relationship or the two sides that are being related by that trig function. And remember, it's going to change based on our angle of reference. If this is our angle that we're talking about, the opposite side is across from that. If this is the angle that we're talking about, the opposite side is across from that. The adjacent side is always forming the angle with the hypotenuse. And here, adjacent side is forming the angle with the hypotenuse. All right, so let's use some trig functions. So we're going to try to find the length of x. So we don't really know what trig function to use until we see what information we're given. So this is our angle that we're referencing. We are looking for this side, which is the adjacent side, and we're given this side, which is the hypotenuse. So we're talking about the adjacent side and the hypotenuse. The trig function that relates those two things is cosine. So we're going to do cosine of the angle, cosine of 30, equals the adjacent side, which is x, over the hypotenuse. Cosine of 30 is just a number. So that function, it's basically just calculating a decimal. Cosine of 30 is that decimal. Always make sure your calculator is in degrees, not radians. Radians is really how an angle relates to a rotation around a full circle, which we could talk about that same thing with degrees. Radians deals with it in terms of pi, where degrees is what you're familiar with, where it talks about the angle that we're rotating. So always make sure your calculator is in degrees. So that would give us that decimal of 0.8660 equals x over 8. And now to solve for x, we're going to multiply by 8 on both sides. If you type 8 like this right here, that is incorrect. That's thinking we want to find cosine of this, which would be 240. That's not what we want. We want it to find cosine of 30 and then multiply that value times 8. So that gives us x. This length is 6.93. I'm going to round to the hundredths place on all of these. 6.93 is the length of x. If you happen to flip these two, let's say you thought that you had the adjacent side and you were looking for the hypotenuse and you put 8 over x and you solved this incorrectly, you'd end up getting a number that's bigger than 8, which you should be able to just use common sense to see that that is wrong, because the longest side of a right triangle has to be across from the right angle. So 8 has to be the biggest side in this right triangle. So we know that number has to be less than 8. All right, looking at number 2, we want to find the length of x again. We're given this angle. We want to find that one that's adjacent. And we're given this one, which is the hypotenuse. So it's the exact same relationship as before. We're going to do cosine of 45, and that equals x over 6. So you're going to see me do this a lot when I do this in the calculator. I'm not going to split this into two separate steps. I'm just going to do this in one step. We're just going to multiply that 6 over. So I'm going to do 6 times cosine of 45. And I can just do that in one step there. So x equals 4.24. Again, it had to be shorter than that 6 because that's the hypotenuse. All right, now we're going to find A and C. So we're given B, and we're given this angle of 28. I'm going to find A first. So I'm looking for the one that's across from that angle. So I'm looking for the opposite side, and we're given the adjacent side. So you want to think about what trig function relates those two, the opposite and the adjacent. That is tangent. So we're going to do tangent of 28 equals the opposite, which is a, over the adjacent side, which is 15. So we could do 15 times tangent of 28. So a is 7.98. And actually, you can kind of check to make sure that that one's right also. If this is 28 degrees, this has to be bigger than 28. It's got to be 52 degrees. Across from that, that side has to be bigger than this side because it's across from a bigger angle. Remember, we learned about how angles relate to their opposite sides. If this is 28, that's 52. Across from that side has to be bigger. So 15, we knew it was going to be a number smaller than 15. All right, then finding C, actually that's going to be cosine again. We're given the adjacent side here. We want to find the hypotenuse. So we can do cosine of 28 equals, now we're given the adjacent side and we're looking for the hypotenuse. So we're going to put 15 over C. This is not as easy to solve. We're not just going to multiply the denominator over. We have to imagine how we would solve for C. So I'm imagining this in two steps. We multiply by C on both sides. That cancels out here. That gives us C times cosine of 28 equals just the 15s left over. And now we want to solve for C, so we want to get this completely by itself. So we're going to divide away this entire function here, which, remember, it's just a decimal. We're just dividing away by that decimal. So you divide by cosine of 28. So this is going to be the value of C, 15 divided by cosine of 28. So that's about 17, really I'm going to label that as just 16.99. All right, on number 4, we're looking for the length of RQ. So we want to find the side that is opposite the angle that we're given. And we're given the side, that's the hypotenuse. So we're trying to relate the opposite to the hypotenuse. So we're going to use sine. Sine of 42 equals the opposite over the hypotenuse. So we could do 14.5 times sine of 42. That tells us that RQ has a length of 9.70. And number 5, we're going to need to draw that picture. So I'm going to draw any right triangle. Angle B is 25. Angle A is my right angle, so that has to be C. And AB is 6. I want to find the length of BC. So I'm given the adjacent side, and I want to find the hypotenuse. I'm using cosine again. Cosine of 25 is going to equal 6 over BC. So again, we can't just multiply over. We can't multiply that 6 over because it's in the numerator. So really, we're going to follow this process. We're going to multiply the BC over times by BC on both sides. So BC times cosine of 25 equals the 6 is the only thing left over there, and then we'll divide by cosine of 25 on both sides. So 6 over cosine of 25 is the length of BC. So BC has a length of 6.62. Again, we always want to make sure that that makes sense. That's the hypotenuse. It's got to be longer than that 6, so that makes sense. All right, now we're looking for the height of the Washington Monument. We're looking for this Y when we're given this bottom side and the angle of elevation. That's the angle from the ground straight up to the peak of the Washington Monument. So we want to find the opposite side. We're given the adjacent side. Which trig function relates the opposite and the adjacent? We're going to use tangent of 78.3. That equals the opposite over the adjacent. So we could just multiply that 115 over tangent of 78.3 times 115. So it is 555.31 feet tall.